Okay, so first thing first, I'm going to the view as per normal. Yeah. So from here, since this urinal is done, I try to use this, or if not, this one can be deleted. Okay. So these two guys, what is a space? Of course, normally, when you plan all this adjustment, ideally is center. So at least when you prepare the pipe segment, the section, right, when you cut, yeah, at least you can cut the same length. So it's easier, right, to manage that way. Normal kind of wastage lah. Yeah. Okay, so 340. So RP 340 divided by 2 is 170. Okay, so I'm going to offset 170 somewhere in the center. Yeah, like that. Okay, now this part here, I'm going to delete away because not required. This part here, I'll maintain, but this connection here, adjust it, delete. Remember, we don't need that. So here, hopefully you guys can understand how this thing is connected. Well, while you are dragging it, remember, not horizontal. Fidget a bit, you should get something like this. It says parallel and nearest. So from there, you get to maintain. The important thing is what? Your slope percent. Okay, so slope percent achieved. That's good. Now, sometime if your pipe or this connecting fitting is too near, you might not able to get the pipes done. I mean the pipe size created. Okay, so all this you can shorten it. Yeah. Okay. So center to center. If I try to draw my pipe from here, okay, and see can I make it? See, this pipe is pipe size.
32. 32.
Okay, so 32. If let's say if the space allowed, maybe I'll get the size. Wow, one size bigger. So this is good. 40. So Santos, you tell me is 40 just now, right?
Yeah.
Yeah, good. So I'm going to get the pipe, which is the pipe. Where is my pipe? Here. Okay, PVC 40. Pick a point and you draw it. Slope off. Slope percent 0. See, this is what I mean. When you draw like this, you can snap. I just don't get it connected. See, weird, right? It doesn't want to work. Interesting, right? Never mind. Let me delete the way. Let's go to the section and change it. So from here, I'm going to align AL reference align. Go back again. Right through here. Now should not be a problem. Hopefully, it's still pretty tricky. Now, what is this pipe size? 32. I'm going to change it to 40. Yeah. Then draw from here. Pipes 40. Highlight the view. Snap it. Hopefully that is connected. See, it works. Actually, the section AA is much more accurate. is better. So I don't know why. Of course, here you can change wider, also can. All right. Why? You are supporting the flow smoother that way. But of course, sometimes it becomes like too many pipe size. So it depends. All right. So done. No change. Delete this away. And of course, here, remove your connecting. All right. Unless you want to cater for expansions and so on. Okay. So if you decide to change this in between pipe, maybe bigger, I'm okay also. All right. Because the flow supposed to be small, bigger, and bigger by right lah. But sometimes because due to the cost, also too many pipe also create problem. Why? You have a lot of adapter, reducer, all these things. Okay. Okay. So this is good. Lower a bit. Yeah. Then now I change back to one of it. Okay. So align. Am I too fast? Okay, right.
Yes, sir.
Okay. So I'll go to modify, align, set the center, align my section line. But I can see sometimes quite difficult to adjust. So must use what? Tab key. Tab key is the tab is to toggle your selection. Remember. So once you set it correctly, then things will be easier. See, now connections is back. Okay, once it's done, now you decide to plan. Okay, so first thing, you must have a trap P. So trap P, whether too high up or too low, that because depends on the accessibility and the view. Okay. Um, Fitting, you need to select is the trap P, which is this our trap P in other country is using this, like Japan, US, and so on. All right. I think US is more or less direct. Japan, it does have a track a U. Ours, we really is a T. Singapore one is a T. You see, US one is a S itself. Yeah. So different country use different stuff. Okay. All this is not so-called right or wrong. You just set their practice. Okay. As long important, it doesn't cause any choking, then it's okay. Okay, when you start to adjust it, cannot be too high up. Like the urinal, we adjust higher because there's no cover. Normally for Singapore tap, like the vanity type, they have a wooden casing or some other uh, precast kind of component they can conceal inside. In that case, you got to adjust the height because servicing. Okay, how you going to service when there's a blockage? So if I do something like that, that is too high up, right? Because remember, your sink itself behind there's a mounting bracket to mount the sink on the wall. So if you go to up, you can't adjust. So this um, trap, it should be somewhere lower like this. Yeah, cannot be too high up. Okay, can? So take note that of course all this is estimated lah, right? End of the day depends on the connection because I didn't really measure it. But to me is sometimes you build things must be logical sense, Okay, now from here to here or connect to here is similar like what you are doing. But I want to show you something interesting, which is since we have advantage is they are both identical and the height, you know, um, is the same. So I want to do something unique because I mentioned before, right? If based on this, the water goes straight, sometime if the flow not fast enough, you flow back, agree? So here, no matter what, must have a slope. But what happened? I introduce another trap here. It means an S like this, then go up. That means if the flow, if here is short, so it pushes the suction. You know, water pipe, right? On top and below. If the water on top will auto flow to below, right? Because of the gravity. You get what I mean? So actually it flow faster. You agree?
Yes, sir.
This is physics. We go back to physics. So I'll do something special. Okay, see how you do it. Santos, yours is do up to you. If you want to redo and try, go ahead. I just
Can,
want to
can,
share with you. Yeah.
can.
I will say that not many people will design something like this, but I just want to explore. To me, since you are doing modeling, a lot of things is possible. All right, so slope down. It's just that sometime it's how people want to do it that way. Yeah. Okay. So if like this, I will bend out this. Yeah. Okay. I think this one can be straight, need not to be slope. Let me undo. Because not much kind of teeth if the slope is only quite short. So let's say 1, 2, 3. Okay, then you turn for here. You get what I mean? Like this. Of course, this part here, the mounting should be slightly out because the bracket cannot be inside. For this case, we got no choice because it's quite near. Unless this design got bracket is outside. If not, this connection we got to create bigger. All right,
Sir,
which
you
is
pull
not the
slow
correct
one.
way. Hmm?
You pull slow bar.
This one?
Yeah.
I
No,
didn't.
right.
No, I didn't. So for this case now, this is too inner. I will just adjust a bit, move out. So it should be like this. Yeah. Okay. This one fix we can't because of the design. See, this particular sink design in US, they don't need this. So they can actually have one way out. Okay. But here, if possible, I will set lower lah. I will just double check how is this connection here. If can lower, I will set lower because okay, something like this would be challenging. Okay, so from here, right click, draw pipes. Somewhere in the center. Then if 45 can join 45, but now stop it. So gotta get the fitting is this one M way means metric degree double. Yeah. Insert it in. Yes, remember the orientation. Select, rotate, flip. Because this is in the cavity. So up and down adjustment is all right. Important thing is the flow. The water flow is important, critical. So select, point, right click, draw pipes. 45. Okay, so here, hopefully when I drag and join, it should, good. See that? Okay, so done. 3D. This is how it look like. You see, joint, too many joint, as I say, as far as gravity concerned, the leak is minimum, but pressure pipe try not to have many joints lah, normally lah. Oh, because you give the chances of leaking is higher. Okay, gravity pipe not so bad. Yeah, so this is one of the way also. Okay, so this is what I try to show to you all. All right, if I lower it, the piping is even quite interesting. See, it's adjusting it accordingly. See now. All right, so you guys decide how you want it. You do this way or you do this way, all this is not wrong. But a lot of people sometimes is like, as I say this case, right? From here, they turn directly. There's no in between connection. That means this one is support to turn at corner. In rower lah, but here computer don't really accept unless you want to rotate it yourself. It can be done. Use the rotate function, you rotate. Or when you draw the time, your pipe is at the angle immediately. So in other words, this and this, your alignment must be there. Yeah. Okay. Of course, this way look nicer lah. It present nicely, easier to connection. Okay. So all this is always plus and minus. All right. It depends on the installer, the guy that installed this, how they want to get it connected. Oh, so all this, as I say, is not wrong. We are doing modeling. So what we are testing is like, hey, how I do my piping. So with this type of design work, yes, you might say waste money, more materials are used, but at least the modeler understand, oh, this one you design, it has a logic behind. Okay, yeah, physics, I will say that. Okay, lastly, if you don't want to recreate one more time, you can mirror. But one thing bear in mind, if you do mirror, you could do some adjustment because you'll notice that the connecting component, not all are visibly set correctly. What I mean is, if I delete this away, I will mirror the whole piece over to that side. And you see what happened to the connecting joint. When you see the line disappear, some part, that means it's not properly connected. That will be a leak in computer. I mean, in their so-called own detection by the software itself. They're very smart one, okay? So let's give it a try. Window this, selected right, mirror using this one. What is this one? This command, mirror pick axis. All right. So by doing that, you just need to select the reference plane and it mirror to the side. So here looks okay, but you see all the connecting part. See the missing link, missing line, the missing line. Look at it. It's not properly connected because to the MEP connection, that means the system. Mirror is like cheating lah. Because you don't represent the actual relationship between the parts and joint. So you got to do adjustment. So let's say based on the current view I can see from now, this one, you got to select the pipe. You drag and you ensure that the O snap core point appear. Then you let go. And then it now should be connected. See? So this is the step you must remember to do. If not later, you didn't do just mirror, you go to analyze, you try to select the piping connection here. You say it's not connected. Sometimes it still does, but logically, when you do modeling, you must observe what you actually model out. Okay, don't let the system tell you because we are only a small part. In real world project is a lot. All the piping is all over the place. So you don't need to every time do the checking, right? You feel headache. All right. Yeah. When you model, you understand the logic there, then you connect. So now I will see from here, from my other section view. So plan, I'm going to align my section line to this. All right, the last sync. So modify, align, center, center. So Chachu coming in. See, it's not, look at it. Adjust it, point, let go. See, now it's done. So it's all good. Okay, so you're in 3D, we are good. This part here, delete, and you get the plug. Where? System, fitting, where's the plug? On top, I believe. Yeah, see, M plug. Zoom in, snap. They auto resize, so no worries on that. Okay, so this piping done. Questions? If not, I will stop the recording.